How you doing, Brandon Hall students? This is Mr. Ross, your math teacher, and today we're going to talk about statistical studies. So some things you should be able to say by the end of the period or at the end of the lesson is, you should be able to say that I can identify different types of statistical studies. You should also be able to say, I can explain the difference between qualitative and quantitative data. You should also be able to say, I can recognize bias in statistical studies. So those are things you should be able to say at the end of the period. Some key vocabulary that you're going to be discussing in this period is, you should recognize that the vocabulary you're going to learn are the words placebo, convenient sample, random sample, experimental study, stratified sample, control group, cluster sample, treatment group, systematic sample, census, parameter, and statistic. So let's begin. Our first word we're going to find is population. So some of these are kind of wordy, so I'm going to give you the printed out version of some of these words. So the first word we're going to find is population. A population is basically the entire group. So in short, a population is the entire group. The rest is the entire group of objects studied or can be considered a collection of all outcomes, responses, or measurements. But just keep in mind, a population just means the entire group. A parameter is our way of describing a population. It's a measure of the entire group. So a parameter is a measure of the entire group or the entire population. A sample is a subset of that population. Let's think about this. Let's say we are living here in Atlanta, Georgia. Let's say this whole big bubble here is Atlanta. It's all the different areas of Atlanta. Atlanta would be the population. It would be all the people in Atlanta. Now within there, we have the little subsets. This subset could be people who live in Sandy Springs. This subset could be people who drink coffee in the morning. This subset could be all the people who go to Brandon Hall School. So all these are different subsets of Atlanta. So this is called a sample. Each one of these are samples. We can take samples out of that population and study them. So whenever we take a sample of that population, what we're taking is a statistic. So a statistic, by definition, is a measure or count of the sample. So this whole class is statistics, and we basically measure and counting samples. That's basically what it is. It's a branch of mathematics where we pretty much just study numbers and study data, opposed to doing a lot of computation with those numbers and data. So that's what we're doing. We're studying different samples of different parameters or different populations. All right, so number 3 says, list the reasons why we might use a sample study instead of a population study. Here's some good reasons why. For one, using a sample study is quicker. Like if I want to study the whole population of something, it may take a while. For example, if I was studying the whole population of Atlanta, there's about 6 or maybe 7 million people here. So because of that, to study every single person in that 7 million people, it could take a long time. So to take a sample or a subset is actually going to be way faster. Like if I just took a random sample. And keep in mind, you want a random sample. Whenever you want a sample, you want a random sample. And in statistics, we accept a good random sample if it's 30 or more people in that sample. If you got 30 or more randomly selected people in that sample, we consider that a good sample. Now, again, the more you get, the better. Like if you got 1,000, of course, it can give you a better idea than 30. But as long as you got 30 or more, we consider that a good statistical sample. And again, it's got to be random opposed to not being random. So that's a better sample. All right, anyway, so using a sample is quicker. Another thing is using a sample is more cost effective. For example, to survey a whole population like Atlanta, or 7 million people, there's a whole lot of surveys to get out. There's a whole lot of people who have to count those surveys and study those surveys, opposed to studying 30. Like you may can do that on your own. And speaking of quicker, in the United States, we do a population study every 10 years called the census. It takes 2 years to finish the count. It takes 2 years to finish counting all the people we think are here. And even then, we don't have everybody. Even then, we have a margin of error where we understand that we couldn't count everyone there. So anyway, using examples is quicker and is more cost effective. And actually, sometimes more accurate to use a sample than the whole population. All right, here's the next example. It says a recent survey by the alumni of a major university indicated that the average salary of 8,500 of its 250,000 graduates was $123,000. Does this value describe a parameter or statistic, and why? So let's think about that. All right, so the whole group of the graduates is 250,000 people. We didn't measure all of their salaries. We only measured 8,500 of them. So for that reason, it's a statistic. And the reason why is 8,500 is a subset. So this is a statistic. Notice that it didn't say it was a random sample, 8,500. They could have just sampled all the people who had a degree in medicine or doctors, or all the people who had degrees in aviation or pilots. So for the record, it does represent a statistic because that is a subset. But I do just want you to start noticing, okay, is this a good study? Have they made me believe that this study is something I should be able to trust? And by listening for the word random sample, or let them tell you who they actually sample, is is something you're gonna start noticing more and more often now that you study statistics. All right, going to the next one. The next one says a survey of 976 American households found that 32% of the households own 2 cars. Identify the population and the sample. So let's think about this. In this, 976 definitely does not represent all the households in America. So if that's true, then the sample is the actual 976 American households that was included in the study. The population is all American households. So that's the population. So we can now identify the sample and the population in that study. All right, number 6 says, identify each following data set as either a population or a sample. I'm going to pause the video and let you think about what each one of these are. So you can put P for population and S for sample. And after you've thought about it, then we'll come back, we'll answer them. All right, number 6 says the age of a few randomly selected participants in a study about a race of runners. So basically, it says you got a few randomly selected. It tells you right now it's a sample because you didn't choose all the runners, just a small subset of them. So this is a sample. The next one says the annual salary of each full-time teacher in a study about Phoenix High School. Well, if you said each full-time teacher, that's all of them. So that's an entire population. That's population. The next one says a study of 750 Georgia homeowners and a study about all the Georgia's homeowners. Well, there's more than 750 Georgia homeowners. So for that reason, it's a sample. There are millions of Georgia homeowners. All right, now on to the next set. It says identify each numerical value as a parameter or a statistic. Remember, parameter measures the population, and a statistic measures the sample. So right now, read these 3 and answer them as parameter or statistic. I'm going to pause again and then let you have a chance to think about them on your own. I suggest you pause it too. So hopefully you thought about it and you read it and you paused it. And the first one says, of a company's employees, the opinions of just those that were there on time one morning about what they thought about the new training program. So they didn't test all the employees, they tested just the ones who were on time one morning. So this is a statistic, it's a sample. Number 10 says, in a study about a small company of 25 employees, the range of their employees' salaries. So you got 25 total employees, so we can do a study with that. It didn't say we did a subset. So this is a parameter, but it's an entire population there. 11, in a study about the value of American homes in 2012, the average decrease of all the homes sold in Gwinnett. So we're doing a study of all American homes, but we only study one county in Georgia. So that is definitely a sample. All right, hopefully you have a better understanding what a sample is and a parameter, or a statistic and a parameter is. All right, so usually to take part of a study, usually they have some kind of sampling frame that they use to decide who the population in the study is going to be. And let's have a volunteer sample. You have this thing called a volunteer sample. One type of sampling is called volunteer sample. A volunteer sample is pretty much what it says. You probably heard a lot of commercials about this, and we'll show a Google search about COVID vaccines. Like you probably saw a lot of different volunteer studies for the COVID vaccine, where people saying we can't do it without your help. We need you to volunteer, be a part of the study, so we can try this vaccine out on people and so forth. So that was a volunteer sample. People lined up and they volunteered to be a part of the study, and then we, of course, are going to benefit if the study proved that their vaccines work. So that's a volunteer sample. All right, another type of sample is this. It's called a stratified sample. Basically, a stratified sample is this. Clearer. As a population is divided into at least two groups, then some members, but not all members, are randomly selected from each group. So think about this. Think about a hallway full of students with classrooms in them. All these students represent a population of people. Then instead of having them all together in one big group, we group them in classrooms. So now we put them together in groups. And then it makes a stratified sample is instead of randomly selecting people from the entire group, we randomly select people from each of the classrooms. We just go down the hallway, randomly grab two people here, arbitrarily grab somebody here, arbitrarily grab somebody there, randomly grab each person from all those. So once I do all that, I got a sample, and it's somewhat random. We call that a stratified sample because we grouped them first in their own little bowls. Then we select from each one of the little bowls. That's called a stratified sample. A cluster sample is slightly different. In a cluster sample, the population is divided into groups. Then all the members of one group, but not all the groups, are selected. So that means that instead of just randomly selecting somebody from all the classes, so all the classes has a representative, we will randomly select 4 groups of classes and say, okay, I'm taking all the people in biology, all the people in art, and all the people who take math. And they ignore the people who are in theater, they ignore the people who take gym and history and science and foreign language. So they ignore large groups of people. They'll have no representatives in this population, in this study. This is called a cluster sample, where you randomly group people in their own little groups, little pots, little pods. And you take entire pods and let that represent the whole study, opposed to taking somebody from each of the ones, like a stratified sample. Again, it's called a cluster sample. Take entire groups within the groups you created. A systematic sample is this. You may have been a part of one of these. A systematic sample is the population is ordered in some way, and every nth member is chosen. So it was like standing on a street corner and counting every 6th car and deciding whether or not the person is wearing a seatbelt or talking on a cell phone. That's a systematic sample. Instead of asking everyone or surveying everyone, they survey every 5th person or every 6th person or somewhere like that. That's a systematic sample. And the last one is a convenient sample. A convenient sample is sampling members of a population that is readily convenient or readily available. It's kind of like this is the laziest way of doing a sample. It's not a great way of doing a sample, but it is a way of doing a sampling. So it's just just measuring people who are right there at your disposal and letting that represent the whole group. For example, if I wanted to test how people felt about the weather today in Atlanta, and I only questioned the people in my 5th period statistics class or my 8th period statistics class, that would be a convenient sample. It's a sample. I did measure people who live in Atlanta, but I didn't really measure everyone, just the ones who I could easily grab a hold to. Anyway, so that's a convenient sample. Now let's actually put that to use. All right, so take about 3 minutes to read these questions and to choose whether or not each one is either, I'm gonna make it fit in the screen now, but you can choose whether or not it's a random sample, where you just randomly choose people, a stratified sample, a cluster sample, a convenient sample, or a systematic sample. And again, random sample didn't appear on the page, but basically a random sample is when you randomly choose people. Like you might use a computer program to generate everybody with 2 digits, and then you randomly choose all people from those 2 digits, kind of like a lottery. Like a lottery is a random sample or a raffle. Like give everybody some kind of number that you randomly choose from everybody's numbers. That'll be a random sample. But going back to this page, try to make it fit into the screen. And use what you know about all those samples to see if you can answer those. Good luck. All right. Hope you had a chance to think about them. Let's do them. The first one says there are 250 seventh graders and 300 eighth graders in generic middle school. We asked 45 seventh graders and 50 eighth graders how many siblings they have to compare with the 2 groups. All right, so let's think about this. You got 250 people in this whole population that's 7th graders and 300 that's 8th graders. And they asked 45 of the 7th graders and 50 of the 8th graders. So they asked a small group from each population, right? So you got to decide whether or not it's stratified, cluster, convenience, or systematic. Because they asked a small group from each one of those populations, that sounds closer to stratified. So STR. Like they didn't just choose all the 7th graders in Mr. Ross's class, or all the 8th graders in Mrs. Johnson's class. They choose somebody from the whole group. So that's stratified. The next one is ask all freshmen and no sophomores and no juniors, and all of the seniors if they prefer vanilla or cherry Coke. These are 4 groups and my only 4 groups to create a study of what should be in the vending machines. So you got freshmen, I'm calling it 9th, freshmen, sophomores, juniors, and seniors. And you ask all the people in the freshman group and all the people in the senior group, but no one else in the other 2 groups. So it's cluster. So I'm taking just a small group. I'm taking entire groups to represent everyone else. 19 says, I asked everyone in my 5th period class who has more than 1 computer at home in a study about all my students for the year. So I only asked my 5th period class students about what they have to study everyone. So this is definitely a convenient sample. So you should have wrote convenient sample there. Number 20 says, I collect data from every 15th student on my list of the entire school population. Every 15th definitely says it's systematic. This is a systematic sample. And the last one says, after using a random number table to generate 2-digit numbers, I decide on 10 people to choose from the population. So you give everybody a 2-digit number, and of those numbers, you choose 10 people at random. This is definitely a great way of doing a random sample. Probably the best way of getting a random sample. Giving everybody a number and then selecting for those numbers, just like a raffle. All right, so anyway, that's what they are. All right, now let's look at different types of studies. This one is, the first one would be an observational study. Observational study pretty much works like it sounds. I'll give you a definition for it here. Observational study attempts to study cause and effect, but the researcher is not able to control how the groups are assigned or the treatment each group receives. The researcher also usually attempts to minimize any influence he has on the study and may have on the subjects. So it's observation. He tries to be hands-off as possible, and he only looks. He only observes what's going on without actually trying to physically change any of it. That's an observational study. The next one is experimental population. Experimental study is a type of study, this type of study, also attempts to understand cause and effect relationship. But this time, the researcher usually selects groups from the population and assigns treatment to one or more of the groups. The researcher also commonly uses a control group who receives a placebo. A placebo basically means fake medicine. Fake medicine. Um, so it's basically like everyone else is given a real medicine or the real vaccine, and he's given a placebo or a fake medicine or a fake whatever the thing is. And they just want to see if there's any difference in people who actually receive the real drug compared to people who receive some phony drug that has no effect and shouldn't do anything. It's kind of like a water pill. I want to see if that actually shows any difference between one and the other. All right, treatment group. This group actually receives the real treatment, actually receives the real medicine. And control group, or the experimental group, this group receives the fake treatment called a placebo. So that's a fake treatment or fake medicine that doesn't do anything. And some people actually claim to have some changes done, but we know they have a placebo. So we know that they shouldn't have had any changes happening. Any change they report, they would have made it up because they had a fake. All right, simulation is another type of study. A simulation is a way to model random events in a statistical study such that you simulate outcomes closely match real world outcomes in a safer and more effective way. So for example, if you want to test whether or not cars are effective or safe when they crash, you might see those pictures with the crash dummy in the car. So you wouldn't actually put a person in the car to see if they get hurt, but you would use something to simulate what an actual crash would look like and so forth. So that's a simulation study. Next one is a census. A census is the study that uses counts or measures of the entire population. All right, so census are part of parameter or parametric study. Going on to the next one. Sampling. Sampling is a study that selects a subset of a population to estimate the characteristics of the whole population. So this is all about statistics. We take samples to figure out what the whole population thinks about a certain candidate or something else. All right, so now let's put it to use. I'm going to give you some questions, and you're going to choose which study is happening in each one of those questions. So, all right, so you can choose type of study that is most likely to be used. All right, so looking at this, you want to know how many pets a teacher at Phoenix High School has. All right, so would you take an experiment, a simulation, a census, a sampling, or an observation? I'm gonna give you guys about 3 minutes. You can pause the video and answer these 5 on your own, and then we'll come back and start answering with you. So take a minute to pause. All right, it's been about 3 minutes. Hopefully you had a chance to think about it. It says you want to know how many pets the teachers at Phoenix High School own. So that's a census. You would just ask them all. And the next one is a drug is given to 15 patients and a placebo to another group to determine the effects on the illness. So this is definitely an experiment where you have some people actually get the drug and some of them get the placebo, which is a fake. So this is definitely an experimental study, so E. So I've already used experimental, we use census. You're doing a study at a mall in which you're counting the number of men that wash their hands after using the restroom. So this is observational. You're just looking. You're not giving them directions on they should wash their hands. You're just observing. You want to know the G-force a person will experience during a fall from a 90-foot high bridge into a lake. Now, you wouldn't use a real person. You'd probably use a dummy to measure what's happening. So this is a simulation. And the last one is you need data to average on the average number of hours worked per week by an American teenager with a part-time job. So you probably sample people. You'll probably get a sample of 30 or more teenagers, a random sample, 30 or more teenagers, XMP. 30 or more teenagers, and that'll give you a good idea of what teenagers across America do. Okay, so this is the last page. We have two data types. One is qualitative and one is quantitative. Qualitative is think about using names or something like that, something that doesn't have value. Quantitative, you're using numbers. You order them in numbers or ways with value. That's basically if I had to simplify, that's what it is. Here are the definitions though. Qualitative is information about quantities, information that can't be really measured. All right, so usually described with category description or names. So that's qualitative. Can't really be measured. Quantitative, information about quantities, information that can be actually measured. As a numerical description with numbers that can provide measurement or those numbers mean something. All right, so think about qualitative being like jersey numbers. Like you usually remember the person's name and number, but they don't really matter much, like what number a person wears. A bigger number doesn't mean a person is better or taller on a jersey. If a person wears a number 99 or number 1, it doesn't mean anything. It is where we describe who he is. Quantitative numbers mean something like a weight or height or distance. So that's the difference between the two. All right, let's put it to use. I'm gonna give you this set of questions. Your job is to decide whether or not this is qualitative or quantitative. So I'm gonna pause the video, let you think about whether or not those questions are qualitative and make it fit in the screen, or quantitative. So I'm pausing it, take about 3 minutes, think about them now. Hopefully you thought about it. The color of automobiles used on a car lot, on a used car. So anyway, the colors don't really matter, so that's qualitative. The number of seats in a movie theater, that's quantitative. We can measure that, and that number matters. The number on shirts of a girls' soccer team, right? So the jersey numbers, that's qualitative. So the numbers don't tell you much about them. The age of students at North High School, the ages is a number we can measure, and the ages matter, right? So that's quantitative. The temperature of 30 refrigerators, it's definitely quantitative. The amount of fat grams in 24 different cookies, definitely kind of quantitative. We can measure which cookies are less healthy than others by measuring the fat in them. The years the Olympics were held in the United States, so that's quantitative. Like we can go to 1905 or 1906, and we can kind of have a chronological order for them. Marriage status, all right, married, single, or divorced. Well, that's qualitative. Like that don't really mean that's a description. Social security numbers. Like I don't know if all countries have social security numbers, but yes, we do. And basically just a number that is basically your name written as a number. That's all it really is. Like that number doesn't mean anything. It's just the way that we describe who you are. You can identify you. So it's qualitative. All right. Last thing is this. We're talking about bias and sample bias. Basically, bias refers to the tendency of choosing one over another. In short, this is what it is. So in short, bias means choosing one group over another, choosing one group over another. So it means you're biased because you just like that group better. But by definition it refers to the tendency of measurement process to over or underestimate the value of a population parameter. Like you don't have the same amount grouped as you should. It is commonly the reason your sample data may not represent the population very well. So yeah, it has a bias. So all right, so a perfect example is you're measuring the people in Atlanta again, but you take a subset, the only group, this is Atlanta again, Atlanta, but you take a subset of that group, the only ones who make $1 million a year. Well, that's bias. Like if you use that subset to describe how everybody in Atlanta thinks, that's a biased subset because everybody in Atlanta doesn't make $1 million a year. So you have a group that's not really representing your whole population. Sampling bias means this. Sampling bias is a bias in which a sample is collected in such a way that some members of the intended population are less likely to be included. All right, it's basically the same thing here. Like if you want to sample the whole city of Atlanta, and you only take the people who make $1 million, not the people who make $20,000 a year. So those people are not included in yourself in your bias. So that's sampling bias. The best way to avoid sampling bias is use a random sampling. Best way to avoid is random sampling. Sampling of convenience is likely to have sample bias. Sampling of convenience is most likely to have sampling bias. All right, now I have a question for you, and you're going to give me an answer for it. It says, which will most likely be the best representative sample, and which would be the worst sample to use in determining the voting preferences for the next president of the U.S. in the city of Lawrenceville? A reporter asks everyone in the front of the courthouse who they plan on voting for and then keeps a record. B, an analyst gets a spreadsheet and list from public schools of telephone numbers of each resident in the city and has a computer to randomly sort the list and calls the first 100 residents and asks their preferences. All right, and then C, a surveyor leaves a survey at the front of all the restaurants in the city and asks customers their preferences. And D, a surveyor asks all the students at a local middle school their preferences. All right, so we're going to figure out which one is the best representative sample, which one is the worst representative sample for the people in the city of Lawrenceville. All right, so if you ask all the people around the courthouse, I wouldn't say that's very good. I would say that's not great. Because why are they in front of the courthouse? Are they there for some political reason? Are they there because they're on their way to court for some breaking some law? So I don't know if that's a good sample. That's not very great. And the next one, an analyst gets a spreadsheet list from all the public records of telephone numbers, and each representative of the city of Lawrenceville, then randomly sorts them and then calls 100 people on the list. This is actually the best one. Even though using telephone numbers isn't the best way of taking a random sample, because everybody doesn't have a telephone. And then number two, everybody doesn't answer telephone numbers that came from a number they don't know. So for that reason, you're leaving out a lot of people from the community that won't be a part of the survey. But that's the best one on this list. The next one is a surveyor leaves questionnaires at restaurants. Personally, I wouldn't answer a questionnaire if it's at the front door of a restaurant. Probably just wouldn't do it. If my waitress gave it to me in the back of my receipt, I probably wouldn't answer it. So in this case, it's not great because you got a lot of people who want to just respond. You get a non-response bias, which is one definition we'll talk about next. And last one is the surveyor asks all the students at a local middle school their preferences. It's actually the worst. We're getting a good sample. So this is actually the worst, and this is the best. Because you're asking middle school kids, they may not be paying any attention whatsoever to what's going on in the race. Um, so, and also, maybe the middle school kids think just like their parents, right? But maybe their parent is one person, and they got 6 kids in middle school. It's possible. So that parent is now represented by 6 different people who can't vote in the election. So that would be a bad sample. All right, finishing this up, non-response bias basically happens when people don't respond, right? It's basically an example of bias that happens when people just don't respond to the survey. Perfect example of non-response bias is, let's say you went and bought a product on Amazon and you bought that product. Hold on, let's show an example over here. So non-response bias happens basically when you have internet reviews, right? So let's say you went and you bought a product on Amazon and had a 4-star rating or a 5-star rating. Well, the people who probably responded to that product are the people who really like that product or really didn't like that product. So you only really have most of the people who are going to be on the top or the bottom. If you thought it was a 3, like most people either can give it a 5 or 1 star. That's not a star. You get a 5-star or 1 star. If you thought it was a 3-star, you probably wouldn't ever even went to give a response to an Amazon. You probably wouldn't thought much of it to even do that. So generally people with non-response bias basically happens when Most people are going to respond to it. People really like it or really hated it. And you're not going to get a whole lot of people say, well, it's just okay. For example, non-response bias. People are not responding because they just didn't want to participate. Kind of like people not answering their phones. Like, they don't like them, they don't answer the number. It's non-response bias. You're getting a lot of people who didn't participate, who could have gave you good input. Response bias. Response bias, by definition, is a tendency for people to answer questions untruthfully. All right. So it's response bias is a tendency for people who answer questions untruthfully. So let's give definitions of those here. So non-response bias is defined here. As you can copy that if you want. And response bias is the tendency of people to answer questions on a survey untruthfully or misleadingly. So to finish that up, it's kind of like this. Let's say I gave you a survey question. And the question is, are there any concerns about response bias in the following survey? And the question could be, what's wrong with your school? Right? That implies something's wrong with your school. So the question is created to make people respond in a way that may not necessarily be how they really felt. They might feel like the school was okay. If you ask them what's wrong, well, I can find something wrong. I don't like the carpet in the room, right? So that's a biased question. This is another biased question. It says, to improve education, should taxes be raised to fund buildings, more schools? This is biased. This is biased because it implies that building more schools would improve education. There's no evidence that says it's because you got more school buildings in the neighborhood, the education is better. You just got more school buildings. All right. The next one says, is this bias? Why are teenage drivers dangerous? Well, it implies that teenage drivers can't drive. I mean, some of them are, but dangerous, but everybody isn't. So it implies that teenage drivers are dangerous in the question. So this is a biased question. Next one is, how long does it take for you to get to school? This is a great question. This question for a survey is non-biased because you're not leading someone to the answer that you're hoping that they answer for you or they give you. This is a good question. There's no leading opinion within the question. All right, people, that was a long video. Rarely do I get a video this long, but hopefully you got something out of that, and that's one of the topics I'll be testing you on in this unit. That's all I have. Good luck.